In diagrams, definition: representing various relation between sets with the help of diagrams. Here in Venn diagram, the universal set is represented by a rectangle and the subset is represented by a circle. To understand this, let us discuss an example. Let U is universal set 1, 2, 3, 4, 5, 6, and A is any subset of U 1, 2, 3, and B is another subset 4, 5, 6. Now how can we express the relation of A and B with U with the help of Venn diagrams? First of all, what is the relation of A and B with U? Both are subsets of U. B is also contained in U. You can easily see 1, 2, 3, which are the elements of A, are elements of U, as well as 4, 5, 6. The elements of B are the elements of U. Now to express them with the help of Venn diagram, let us first draw universal set U, rectangle shape. What are its elements? 1, 2, 3, 4, 5, 6. So they are randomly scattered in this rectangle, and out of these 1, 2, 3, they constitute A set, and 4, 5, 6, they constitute B set. So this is how we represent the relation between sets in Venn diagram. Now various relations are, various symbols of Venn diagram are. One of them is this. Here A and B are disjoint sets. Disjoint means they have nothing common. So these circles are not connected, they are separated. Now another relation, so we continue this example. In second case, let this be case 1. Now let A is equal to 1, 2, 3, 4, and B is equal to 3, 4, 5, 6. So what will be the relation now? Again, both A and B are subsets of universal set. Now the Venn diagram of these two subsets are, this is U 1, 2, 3, 4, here 5, 6. Now how they are represented? So A is 1, 2, 3, 4, and what about B? 3, 4, 5, 6. You see, this is A 1, 2, 3, 4, and this is B. This is A and this is B. But now we have this part common between A and B. Now another example, third example. Now again universal set is this same U. Let A is equal to 1, 2, 3, 4, and B is equal to 1, 2. Now just imagine the situation, what type of Venn diagram they satisfy. Now before drawing the actual relation between them using Venn diagram, first we see mathematically how they are related. You see clearly A is contained in U. Now where B is contained? See 1, 2. 1, 2 are also elements of A. So B is contained in A further. That means the elements are 1, 2, 3, 4, 5, 6. So they are scattered like this. This is A. This is A. Where is B? This is B. Inside A. Because B is contained in A. So these are some forms of Venn diagram. Now let us discuss various operations on sets. So various operations are, first operation is union of sets. So it is denoted by symbol U. So whenever we encounter this symbol, we read it as union of sets. So first, definition of the union. If A and B are two sets, then union of A and B is all those elements which are either of A or of B or of both. So it is denoted by A union B. Now in set builder form, how it is represented by A union B equals to X is an element of this set if either X belongs to A or X belongs to B. But here you must remember one thing, that the element which is common to both A and B is only taken once. For example, let us take this example again, example 2. Here in this example 2, A is 1, 2, 3, 4, B is 3, 4, 5, 6. Example 2. So from here, what is A union B? 1, 2, 3, 4, 5, 6. You see, 1, 2, 3, 4, 3, 4 we already included, 5, 6. Union of two sets. So we can have union of more than two sets. Like if we have, for example, A is 1, 2, 3, B is 3, 4, 5, C is 5, 6, 7. Then what is A union B union C? Again, all those elements which belongs to A, B and C, and the common elements are written only once. 1, 2, 3, 4, 5, 6, 7. Next relation is intersection of sets. Again, if A and B are two sets, then set of all those elements belong to both A and B is called intersection of A and B, and is denoted by A intersection B. So this is the symbol now, intersection. So thus in set builder form, A intersection B equals X is an element of intersection. You see, X belongs to A and X belongs to B, then it belongs to intersection. So how can we plot its diagram, Venn diagram? Let this is universal set, this is A, this is B, this is A, this is B. Can you imagine where is intersection lie? The common part. This is the intersection. Now, for example, let A is equal to 4, 5, 6, 9 and B is equal to 1, 2, 3, 1, 2, 4, 1, 2, 3 and B is equal to 1, 2, 4, 5. Then what is the intersection B here? What are the common elements of 4 and 5, A and B? 4, 5. One, 2, 3. B is equal to 1, 2, 4, 5 and you see intersection of A and B is 4, 5 because they are common to both the sets A and B. So similarly, another example, example 2, this is example 1. Let C is equal to 4, 5, 6, 9, 11 and D is equal to 4, 5, 11, 12. Again you see C intersection D is 4, 5. Is there any other element? Yes, 11. So this is how we find the intersection. Now from this definition we can draw next definition, disjoint sets. It's very interesting. If the intersection is empty, there is nothing common between two sets, they are called disjoint sets. So definition becomes, if two sets have no common element, then these sets are called disjoint. So how can we represent them? A intersection B is equal to empty. You know, we already discussed the symbol phi. That means empty. Okay, now we proceed to next relation, complement of a set. Again, we let A be any set and U is universal set. then set of all those elements of U which are not in A is called complement of A. So first we write it. The set of all those elements of U which are not in A is called complement of A and is denoted by either A dash or A bar or A power C. All these are the representation of complement of a set. For example, let this is universal set, this is set A, this is set A. Just imagine all those elements of U which are not in A. What are those elements? All these elements which lie outside A. All these elements, they form A complement. Now let us discuss an example. Let universal set is 1, 2, 3, 4, 5, 6, 7 and any subset of U A is equal to 1, 2, 3, 7. Then how much is A complement? All those elements of U which are not in A. What are those? 4, 5, 6. So this is A complement. Now we will try to draw some other definitions also from this example. Can you imagine what is U complement? If this is U universal set complement, you see there is nothing. If that set which contains no element, so that is empty set. And opposite to this, complement of empty set contains nothing, so that means all elements, that is universal set. And one more interesting result, if we take complement of complement, what we will get? We will try to understand this from diagram. You see, complement of A complement, all those elements which are not in A complement, what are those? A. So we again get A. So we can also write it from here. If we again take its complement, all those elements which are not here, what are those? 1, 2, 3, 7. We get A. Okay, next relation is difference of sets. So the set A minus B consists of those elements of A which do not belong to B. You see, difference A difference B consists of all those elements of A which are not in B. So in set builder form, how can we express A minus B? So an element belongs to this set if it is in A and X is not in B. How can we express this by Venn diagram? Let this is universal set, this is A, this is B, this is A, this is B. You see, what is A minus B then? Elements of A which are not in B. That means only this part. So we leave this common part. This is A minus B. So similarly, B minus A. So we can easily write the definition, all the elements of B which are not in A. So X is in B and X is not in A. So Venn diagram is, this is A, this is B, this is A, this is B. So all those elements of B which are not in A, this is B minus A. So let us have some example. Let A is equal to 1, 2, 3, 4, 5. B is equal to 2, 4, 6, 8. So first we try to express A minus B. Elements of A which are not in B, what are those? Which are not in B? 1, 3, 5. So you see, 2 and 4 are already in B, so we leave them. We only write 1, 3 and 5. And B minus A, all those elements of B which are not in A, what are those? Only 2 elements, 6 and 8. So this is how we write the difference of sets. So now we discuss some examples based on Venn diagrams and operation on sets. First example is, find the union of each of the following pairs of sets. This is A, X belongs to natural number and X is greater than 8. And B is 1, 2, 3. So first we are given set builder form. We convert this into set roster form or tabular form. So how much is A then? See, those natural numbers which are strictly greater than 8. 1, 2, 3, 4, 5, 6, 7. And B already in tabular form. So we can easily find the union of these two sets, A union B. So by definition of union, elements of A and elements of B and the common elements are written only once. So 1, 2, 3 are common to both of them, so we can write them once, and then the elements of A 4, 5, 6, 7. So this is union of A and B. Another example, X is a natural number, so this is an infinite set of all natural numbers. And B, X is an integer with X strictly less than 0. Then what are the members of this set? It is interesting to know here. Let us first write B. So strictly less than 0 means all negative numbers. What are the members then? They are of the form -1, -2, -3, -4 up to -infinity. This is B. And A is 1, 2, 3, 4, all natural numbers up to infinity. Just have a look. What is their union? A union B. You see, we all know 0 is not a member of natural numbers, and here we are choosing all numbers strictly less than 0. So we start from -1. So we get all integers except 0. So we have now -infinity to -1, then 1, 2 up to infinity. So this will be the union. Okay, next question. If A is a subset of B, what is A union B and what is A intersection B. So let us try to solve this question with the help of Venn diagram. So this is universal set. A is contained in B. A is a subset of B and B is a superset of A. So this is B and this is A. Now just have a look on this diagram. Whatever we have learned about these operations, A intersection B contains all those elements which are common to both A and B. Whole of the A is contained in B. That means the elements of A are common to both A and B. What is their intersection? A. You got it? So this is the desired answer. Now A union B. As per definition, elements of A, elements of B and the common elements are represented only once. So what is the union then? You see, A is contained in B, so we get these elements and all these elements. So whole of the B is in the union, so union is B. Okay, next question. We have three sets now, A, B and C, and we have to verify this is equal to this. We have to verify left hand side is equal to right hand side. To verify this result, so we start with the left hand side. So to find left hand side, we start with this inner bracket, A intersection B. So putting the value of A and B, A is 4, 5, 7, 8, 10. B is 4, 5, 9. Can you see any common elements? 4 and 5. Now to complete the left hand side, intersection of this set with this C. So this we already calculated. So A intersection B intersection C is, A intersection B is 4, 5. C is 1, 4, 6, 10. So what we get? Anything common? 4. Singleton set. So this is the left hand side. Now right hand side, first we find B intersection C. What is B? 4, 5, 9. C 1, 4, 6, 10. Can you see anything common? Only 4. Now to find the complete right hand side, A intersection with B intersection C. What is A? 4, 5, 7, 8, 10. Intersection with B intersection C. We already calculated this is 4. Now what is their intersection? 4, which is right hand side. So they are same. That means left hand side is equal to right hand side. Hence verified. Next example. Here A is this set and B is this set. We have to find the difference of the sets. Now to find difference, first of all we are given sets in set builder form and we convert these sets into tabular form. So you see A is 4n plus 1 for n natural number n less than equal to 5. What are the values of n less than equal to 5? To find A, so first we write n. N is 1, 2, 3, 4, 5. And the elements of A are of the form 4n plus 1. So first we put n is equal to 1. 4 into 1 plus 1, how much we get? 5. For n is equal to 2. 4 into 2 plus 1, 9. For n is equal to 3. 4 into 3 plus 1, 13. For n is equal to 4. 4 into 4 plus 1, 17. For n is equal to 5. 4 into 5 plus 1 is 21. What are the elements of A then? They are 5, 9, 13, 17, 21. So similarly we find B. Now to find B, n is 1, 2, 3, 4. So elements of B are the powers of 9 raised to power n. So B becomes 9 power 1, 9 power 2, 9 power 3, 9 power 4. That means B is 9, 81, 729, 65, 619 power 4. Okay. Now to find this difference, so we start with, first we find this difference, A minus B. So as per definition we have done elements of A which are not in B. So there is only one element which is common between them, which comes in B also, that is 9. So this is 5, 13, 17, 21. Now next, A minus B. Again, element of A which is not in this set. Just understand this carefully. Element of this set which is not in this set. What is that? Only element 9. Answer.